Hello Legacy Sabers, Marsh here. So today we're going to talk about the second day of solving rational equations. This is different than before. Today we're going to have 3 or more fractions involved. What you're going to want to have on you, your notes, pen or pencil, and then a calculator to do some simple multiplication today. So, long ago, when you're solving with fractions or just solving linear equations in general, you may have learned this trick that you could do, which was taking the common denominator or lowest common denominator of all the numbers underneath, which in this case would be 18, right? And you could multiply the numerators by that 18. Well, what I could do then is I would have 18 over 3x plus 90 over 9 equals 306 over 18. Now, here's what was cool about that though, is that ultimately these simplified down to nice numbers. So 18 over 3, that's 6x, 90 over 9, that's 10, and then 306 divided by 18, well that's just 17. And it made it a 10 times easier for us to solve when we had fractions in it. We're going to use that same idea with our solving of rational equations. We're first going to find our LCD, multiply that by all of our numerators, and then we're going to cancel what we can cancel. Now notice guys, this only works with equations. It does not work with adding and subtracting without an equal sign. So don't try to do this when you're trying to just add and subtract them. Do not only do this when you have an equal sign present in your problem. So example 1 here, I have 1/2 plus 2 over x equals 1 over x. It looks like my LCD would be 2 times x. So what I'm going to do is I'm going to multiply each numerator by 2x. So I'm going to have 2x over 2 plus 4x over x equals 2x over x. Now what I can do is cancel off what is left behind. So 2 over 2's cancel. I'm going to be left with x. Oops, that should have been a plus sign. Silly Marsh. There we go, plus. X's cancel off, I'm going to be left with a 4. And x's cancel off, I'm left with a 2. So if I solve this really, really hard problem now, I'm going to subtract 4. So I'm going to x equals -2 for my answer. Now, just like day 1, you do need to check the original, but remember, all you need to worry about is denominators. Denominators cannot be equal to 0. So 2 can never be equal to 0. If I plug in -2, that doesn't cause a problem. -2 doesn't cause a problem. Checked, nothing wrong. That is the correct answer, and it is not extraneous. Well, let's try example 2, shall we? I have 3x over x plus 1 equals 12 over x squared minus 1, and then plus 2. First things first, I'm going to change this x squared minus 1 into x plus 1, x minus 1. That way I can find the common denominator here. And it looks like that might actually be the common denominator. So this would be a 1, which 1 can just sit right there. X plus 1 I already have, and then I just needed the x minus 1. So let's multiply each piece by our LCD. Like that. Now what I'm going to do is, as I'm standing here when I have the multiplication like this, I'm going to cancel out what I can cancel out. So it looks like I can cancel out the x plus 1's, top and bottom. I can cancel out both of them with this denominator, and then nothing cancels off here. So on my new numerators, I have 3x times x minus 1 equals just good old 12 plus 2 times x plus 1, x minus 1. Okay, now let's actually multiply in just like what we've done before. So 3x squared minus 3x equals 12 plus plus 2, x minus 1, that'd be 2x squared minus 2x plus 2x minus 2. So 2x squared minus 2, like that. Let's get everybody to the same side. So I'm going to subtract 2x squared, and it looks like I'm subtracting 10 because 12 and negative 2 make me 10. So negative 2x squared, negative 10 over here. So I'm going to get 1x squared minus 3x minus 10 equals 0. That does factor into negative 5 and a positive 2 because my a is 1. That's why I can take my shortcut. So I got x is 5 and x is negative 2 for both answers. Now, check your original. Does 5 work in the denominators? Indeed it does. Does negative 2? Indeed it does. So both answers of 5 and negative 2 do not cause issues in the original problem. Let's try the third example here. So looking across from my LCD, looks like I gotta take an x plus 1. Then I need a 2x, because remember this x is attached to that 1. Then I already have an x, so I don't need to worry about that. So let's multiply each of the pieces by this LCD. And I can cancel off what is on the top and the bottom. So x plus 1 is on top and bottom. 2x is on the top and bottom, and then just an x. So I am left with 3x times a 2x for the first part, plus 6 times x plus 1 equals, and then it looks like 7 times 2 times x plus 1. Right? That's what's left behind. So I will have 6x squared there, plus 6x plus 6 equals, that's technically 14, so that would be 14x plus 14. Alright, let's subtract 14x and subtract 14 to the other side. Boom, boom. So I got 6x squared, excuse me, minus 8x minus 8 equals 0. It looks like I need to factor out, because they all share a 2, so let's pull that out, so that makes it easier for me to factor. Equals 0. Cool. A is 3, so I actually have to use grouping this time, so I got negative 12. I need to make a negative 4. Be negative 6 and a positive 2, it looks like. So I'm going to leave that 2 out there as I expand my middle term. There we go. Go ahead and do some grouping. So I got 3x, x minus 2. Looks like a 2. X minus 2. So my answer is 2, 3x plus 2, x minus 2. That should come back to that original problem that I started with when I started factoring. So I have, for answers, x of, well, 2 can never equal 0, so we don't have to worry about that. 3x plus 2 equals 0. That would be a negative 2/3, right? Subtract the 2 divided by 3. And then also x can equal 2. Now let's make sure those both work. Negative 2/3, I'm not going to get 0 there. No and no. So this one works. X equals 2, that's going to be 3. No worries there. 4, no worries. 2 there. Perfect. No problems there. Both answers do in fact work. Let's try the last example of the video. So LCD. Technically there's a 1 there. Don't need to worry about 1s though. I got an x minus 5 and then also an x. So my LCD is probably x minus 5 times x. I am, just like when we were adding and subtracting, I'm going to make that a plus with a negative there. Just before I forget that I am actually doing that. multiply each numerator by the entire LCD. Nothing to cancel off there, but I can cancel off this x minus 5. Got to cancel out that x. There we go. So I'm going to be left with x minus 5 times x, because that's a 1 there, right? Plus a negative 8 times x equals a 3 times a x minus 5. So I got x squared minus 5x minus 8x equals 3x minus 15, because I distribute my 3. Looks like got x squared minus 9, 10, 11, 12, 13x equals 3x minus 15. Subtract the 3x, add the 15 to this side. I'm going to be left with x squared minus 16x plus 15 equals 0. Numbers that make 15 but add together to give me negative 16. It looks like it's negative 15 and a negative 1. So x has to either equal 15 or it can equal 1. Now let's double check. Does that work? No problems in the denominator. 15's okay, 1's okay, 15 and 1 both are okay. So no issues. The only numbers I could not have had x equal to is either 5, because that would have caused an issue down here, or 0. So 15 and 1 are just fine. And that's the end of this video. See you later, Sabers.